Section 5.6, Rational Functions. Suppose we know that the cost of making a product is dependent on the number of items x produced. This is given by the equation c of x, which is equal to 15,000x minus 0.1x squared plus 1,000. If we want to know the average cost for producing x items, we divide the cost function by the number of items x. The average cost function, in which yields the average cost per item for x items produced, is f of x, which is equal to 15,000x minus 0.1x squared plus 1,000 over x. Many other application problems require finding an average value in a similar way, giving us variables in a denominator. Written without a variable in a denominator, this function will contain a negative integer power. In the last few sections, we have worked with polynomial functions, which are functions with non-negative integers for exponents. In this section, we explore rational functions which have variables in a denominator. Using arrow notation, we have seen the graphs of the basic reciprocal function and the squared reciprocal function from our study of toolkit functions. And let's examine these graphs below here in figure 1 and notice some of their features. Well, if we take a look at the reciprocal function 1 over x here on the left, you can see what's happening with this graph. Okay, on the top right, we can see that it's approaching positive infinity towards the y-axis and positive infinity towards the x-axis. And over on the bottom left, we can see that it's approaching the x-axis going towards negative infinity and approaching the y-axis as it's going to negative infinity. Now, when we look at the squared reciprocal function, we can see that on the left side, as it approaches the x-axis, it's going towards negative infinity. And as it's approaching the y-axis, it's going to positive infinity. And if we look at the right side, as it's approaching the x-axis on the right, it's going towards positive infinity. And as it's approaching the y-axis on the right-hand side, it's approaching positive infinity. Now, there are several things that are apparent if we examine the graph on the left here, which is the reciprocal function 1 over x. Okay, if we look at the left branch of the curve, okay, now what it's saying here is that when you look at the left branch, okay, as the curve starts to approach the x-axis, it approaches negative infinity. Okay, so that's what's happening here. So as the curve approaches the x-axis, as x is approaching negative infinity. Now, as the graph approaches x equals 0 from the left, the curve drops, but as we approach 0 from the right, the curve rises. And finally, on the right branch of the graph, the curve approaches the x-axis as x approaches positive infinity. So as it's approaching the x-axis, it's going towards positive infinity. And we can see there that as the graph is approaching on the left, the y-axis, it's going towards negative infinity. And on the right, we can see that as it's approaching the y-axis, it's approaching positive infinity. Now, we want to summarize information, okay, using arrow notation to show that x or f of x is approaching a particular value. So let's take a look at the first symbol. We have x, an arrow, a, and it has a minus sign on the top right. What that means is that x is approaching a from the left. So x approaches a from the left, meaning x is less than a, but close to the value of a. Over here, we're going to say the symbol is x is approaching a from the right. So x approaches a from the right, x is greater than a, but close to a. So the plus is telling you it's coming from the right. The next symbol, x approaches positive infinity. X approaches infinity, x increases without bound because it's going towards positive infinity, meaning it's increasing. X is approaching negative infinity. X approaches negative infinity, which means that x decreases without bound. Next, we have f of x, or we call it y, or the output approaches positive infinity. So the output approaches infinity. The output increases without bound. Over here again, f of x or y, or we can call it the output, is approaching negative infinity. So the output approaches negative infinity, and the output decreases without bound. The last one, we're going to say that the function f of x or y, or the output, is approaching a value of a. So the output approaches a.